Welcome to the training video on how to use the hydrogenation reactor. Hopefully most of this just serves as a refresher on proper things to do. So, it's first thing in the morning and you're going to run a reaction in the hydrogenation reactor. So there's three things you have to do when you walk in. The first, walk over to this cooler and power it on. It needs to reach minus 20 degrees Celsius and it takes about 3 hours. So if you forget it and then try to turn it on during the reaction or just prior to, you'll wind up staying here about an extra 3 hours. The second thing you do, and this is new, is you come around to the side and you turn on the surge protector for the mass flow controllers. They need to warm up for about 15 minutes before you power them on. You'll notice they'll hit their maximum flow rate. This one reads 111, and then it'll quickly go back down to 0. Don't use it immediately, but after you load the reactor, enough time should have passed that you can start to run it. And then third is you remove the reactor from the previous night and replace it with your current reaction, your current catalyst. So you remove the glass wool, and remember, do not move this holder, but this one can be moved however much you want. But usually to take it out, you just need to loosen this piece, loosen this piece, and that should be enough to unscrew these nuts and take it out. This is the reactor once it's been removed. Now note, we've got the thermocouple that's being held to the side with Teflon tape, and then we've got the vacuum seal nuts with O-rings on the top. Now the O-rings, you're not going to find them on the glass itself, so we have this O-ring removal that we can take to the nuts where they're previously placed, and you can take them out and they come back down on the O-ring remover. You can apply just a little bit of vacuum grease and reuse them. At this point, you'll weigh out about 5 to 7 milligrams of your catalyst, or however much was decided before. Make sure you record your catalyst weight and then dilute it to about 1 gram with silicon carbide. At that point, you'll look through your solid to make sure that everything is uniformly distributed, that you don't have large chunks of catalyst just hanging out. If you do, you can take one of the lab spatulas and crush it down. I wouldn't use a mortar and pestle for that. Now with the reactor itself, before you load it, you have to make sure that you're putting in glass wool to the bottom. Now before we were using a different kind of tool to pack it down, but I've taken some 1/8 inch tubing to use as the packing tool. So at this point, we'll put the catalyst into the reactor, and then put the nuts on the end with the O-ring, and add the thermocouple with the Teflon tape. All right. This is after the thermocouple has been put in place with the small wire holders that I've put on the reactors themselves. You want to make sure that the tip of the thermocouple, this is the part that actually measures the temperature, is in line with the catalyst bed. It's kind of hard to see on this video here, but the catalyst bed ends at this point here. So you can see that this will be measuring the temperature at the outside of the reactor for the bed itself. And at this point, I'd show you, but it's hard to do with one hand, is you take some of the Teflon tape and you wrap it around 3 parts of the thermocouple. You want to wrap it around the tip, a part in the middle, and the top portion. Before the thermocouple was removed, you can see previously that it's going to look something like this. And then at that point, we're going to put first the vacuum nuts back on, and then the O-rings on top of those. Alright, now the reactor is ready to be placed inside. You see the second O-ring is down there, and the thermocouple is fixed into place. If you need to use a lot of Teflon tape, that's totally fine. We have a ton of it. You do not need to be in the least bit conservative. So I'll try to explain this as best I can with one hand. When you're putting the reactor into place, you want to make sure that it is, if you press down on it, you're able to push it into the bottom of the furnace. So the first thing you're going to do is you're going to loosen this nut and place this portion over here, and then tighten it into place. And then you can loosen this nut, which will raise and lower the outlet tubing, and you can fix that on top of the reactor. Make sure that you're being slow and a lot more methodical. It's very easy to break these reactors. Once the reactor is in place and the nuts have been tightened, we can take some of the glass wool and insulate the top. You want to insulate both sides around the reactor, so that way heat is not able to easily escape. This will raise the reactor temperature a good 20 or 30 degrees Celsius. And second, you want to attach the thermocouple. It's going to move around a bit. You don't have to worry. It's going to stay on the side of the reactor itself. So at this point, we can start up our flow of gases and commence with our pre-treatment. It's probably been over 15 minutes, so our mass flow controller should be steadied at about 0. This is the hydrogen mass flow controller, and it tends to steady about 0 to minus 0.3. It's kind of hard to tell given the angle, but that's the nitrogen flow controller, and that's reading 0 to about 0.1. The nitrogen controller, I've noticed, has been a lot more accurate than the hydrogen controller. All right, so we want to turn on our helium for the GC. That's the second cylinder here. Make sure that the main valve is open. We're going to start the GC at the same time that we start the pre-treatments, but we also need to make sure that our nitrogen itself is also on. That's our second pre-treatment gas, and that has already been kept on overnight. They're not always kept on overnight. You always want to check these, especially with the mass flow controllers. If you flow them without any gases, it'll throw their 0 off, and we're going to have to recalibrate them. So we'll open up the hydrogen, then open up the main valve to the room, and you'll hear a hissing noise as the gases are filling the line. So while you're opening these cylinders, also pay attention to the pressure on the main gauge. This tells you how much is left in the cylinder. And if you notice, it's starting to get below about 200 pounds. So this little pin is 100 pounds. If it's starting to get around 200 pounds, like the second little mark here, then you're going to have to find a replacement cylinder, because you're going to want to change it by about the time it gets to 100. So we'll come back over to our reactor, and we can open up the gas lines. Nitrogen here, helium. We want to open the lab air. That's going to be used for the GC. And we'll open the hydrogen over here. You'll notice that all the gauges will pop up. Now, if you forget to turn on one of the cylinders, the gauge will probably pop up. This is most notable with helium because there's still gas in the line, but after about 20-30 minutes, all the gas will be gone. And if you're starting to wonder why your GC isn't actually reading anything, it's probably the helium line. So there's a couple of flow rates that we want to keep especially aware of, and the first is the hydrogen. This is the hydrogen that is going through the Alkyne. We want this to be set at about 10 milliliters a minute, and that's set through this rotometer that's suspended here in the middle. So you want to be very, very careful with this. 10 milliliters a minute is roughly right there. In fact, that's maybe a little bit too high. You barely had to touch it. So you want to make sure that that little ball, the top of that little ball is either at the bottom of that first line, or right here, it's about right in the middle. And we can check to see that if everything was tightened correctly, you'll start seeing bubbling come out of the GC. Now, we don't have to measure this one quite yet. We can set the hydrogen mass flow controller with the makeup flow. So the rotometer should flow at about 20 milliliters a minute, or sorry, about 10 milliliters a minute, and the hydrogen mass flow controller should be at about 40. So the way we do that is we take the screwdriver from the side of the GC, and there's a little screw potentiometer you can see right there. And if we move to tighten the screw to the right, this will increase the flow rate. So when it hasn't been on for a while, you usually have to do 4 or 5 complete turns of the screw, maybe a little bit more. And then you'll see it jump from 0, there we go, to about, 18. If you need to go lower, you can push it a little bit lower. We'll just set this to 40. If you're off by 0.1, 0.2, it's not the end of the world. Stabilize that at about 40. And you can push that a little bit more. Yeah, 40.2. We're okay. So at this point, you want to measure your flow rate to make sure that you're getting about 50 milliliters a minute. When you use the bubble meter, this means you'll get to 10 milliliters in about 12 seconds. If you're somewhere between 11.5 and about 12.5, you're all right. If you're a little bit fast, you're probably going to have to lower the flow rate a little bit on the rotometer. We can see that it's already gone down, so you're going to have to readjust that. I highly suggest that once the rotometer's been stabilized, you don't bother with it. It takes a couple of days for us to actually get a stable point. I'm about 2 days into that process right now. But once you verify that you're getting about 50 milliliters a minute coming out of the reactor system, you'll then set your nitrogen mass flow controller to 50. So you're going to have a total of 100 milliliters a minute going through the reactor. 50% of that's hydrogen, 50% of that's nitrogen. Alright, so I finished adjusting the flow rates and turning up the nitrogen mass flow controller to 50. There's a couple of things I want to point out. The first is that the valves to the bypass that go into the Alkyne bubbler, they should be in this arrangement. You should see these two valves here closed and these two valves pointing to the right. That means that you're not going through the Alkyne bubbler. If you're going through the Alkyne bubbler while you're doing a pretreatment, you're going to be putting reactant all over the catalyst under pretreatment conditions, which means you're probably not going to have a good catalyst by the time that we do the test. So make note of that. And the second thing I want to note is with the GC, we can turn this on once we start the pretreatment going. So for the pretreatment itself, it's going to be half an hour at 120 degrees Celsius and then 1 hour at 300 degrees Celsius. So what we're going to do is while this little standby section is blinking, we can turn up the temperature. You're going to turn it to 80. This is an internal thermocouple. It's a lot lower than the actual temperature that we're going to be reading from the thermocouple readout. You know, now that I say this, you should set this to about 85. It's been running a little bit low for the last few months. And this is the thermocouple readout that we'll be using as the quote-unquote real temperature. So once you have this 85 that's set, this will be at about 120. Hold down this last button, and we'll go into a control mode. And if you press up, you'll see this NOR. You go from standby to normal. So if you press the button again, you'll see lights go off. You'll start hearing a little bit blinking and a little bit of a buzzing noise as power is being given to the tube furnace, and you'll start to see the temperature rise. If you set a timer here for about 35 minutes, that should cover the 30 minutes at 120 degrees. It'll take about 5 minutes to get to about 100, 110. So I want to note as well that once the nitrogen is flowing, you'll see the rotometer go back down to about 0. Do not worry about that. That is totally fine, because once you turn the nitrogen off for the testing, it should be right where you set it beforehand. So now that this is flowing, you turn the GC on. So the first thing we're going to do is you find the switch at the side of the GC, the power switch. You turn it on, you'll hear the fans blowing, and that is the temperature of the furnace. It's reading 20. So if we go to the computer, and if you click this icon here, peak 444-64, it'll start to wake up the GC, and it will set it to the last parameters, or the parameters of the last save file. Click OK. And if we look over at the GC, now we can see that the furnace is heating up. If the furnace isn't heating up, once you see that little OK box pop up, you're going to have to turn up the temperature. So if you go to Edit, Channels, and then Channel 1 is the control channel. If we go to Temperature, you'll see right now it's set to 240. If you double click this, this is where you're able to change it. So it may be set to 20 because somebody had saved the file after they had cooled the GC the night prior. That's fine, just set it to 240 and say OK. Then you can just say OK to everything and it should start heating up immediately. So I won't show it here, but your next step, we can see that it's heated already to about 48, 49 degrees. It's only going to go faster from here. After your 35-minute timer is up, just walk over here and turn this temperature up to 225. Through a lot of trial and error, I've found that 225 is where it will sit in almost 300 degrees even. So set it to 225 and set a timer for 1 hour and 10 minutes. After 10 minutes, it should be close enough that you can start that hour timer at the pre-treatment temperature. And when it finishes, I will show you what to do next with the lab air line. But now that we've got the GC flowing, I want to advise you to open this valve to the air line. There's been an issue with water getting into the compressed air system. I'm not sure how long that's going to last. But if you open this valve all the way, you can hear the air hissing out over here. Look for any water which may be coming out of this tube. Right now I'm seeing none. That's a great sign. If it hasn't been used over the course of a weekend, some water may have collected. Doing this will prevent the water from being pushed into the molecular sieve system and then into the GCFID, which is not good for the electronics. All right, the pre-treatment is now finished. You see that we're sitting at about 305 degrees and the setting is at 225. My timer just went off, so we've been at 300 for about 1 hour. So there's a few things that we want to do here. The first is we're going to reset the furnace controller to standby. So if you press the down arrow from here, we're going to go to standby, and you should see the little standby piece blinking here. Standby just means that we have cut off all power to the GC, so the temperature will slowly go down at this point. Now, we used to just take out the glass wool insulation on top, which I'm going to show you here. You want to be very careful because it's you'll feel that it's quite hot at the top. So you want to remove the insulation so we can drop the temperature even faster. And we used to just do this, but we found a way to decrease the amount of time we're waiting. So if you go back to this air valve, you open up the needle valve all the way. There should not be any water pouring out. And if there is, just wait a couple minutes for all the water to be evacuated, and then put it into the furnace. You take this tube, you can rest it right here, and just let it blow air into the furnace. You can see already that the temperature is going down quite quickly. And there's really two things that's going to be cooling down. It's going to be cooling down the overall temperature of the reactor, and it's also going to be cooling down the temperature of the furnace. The temperature of the furnace is the one that takes the longest because that's this white foam insulation that we see here. So if you wait until the temperature reads room temperature and you put the glass wool insulation back on, it's going to wind up going up another 40 or 50 degrees. So at this point, set a timer for somewhere between 50 and 60 minutes. And when that goes off, turn off your air. So at this point also, we can turn off the nitrogen. A lot of this becomes test specific at this point. But the nitrogen does not under any circumstances need to remain at 50. So you turn the temperature back, or you turn the flow reading back to 0. And you will turn it until you start hearing the clicks of the screw potentiometer. Will go off a couple of times each turn. And it's hard to see right now. It's reading 5. Fail. The dangers of using one hand. Clicks may be hard to hear, but now the nitrogen is at 0. And at this point, you can turn the valve off if you're not going to use nitrogen anymore. If you're doing a hydrogen order plot, then you are going to need to use it at multiple points. I'm just assuming a light off curve here, so I will shut this valve off. At this point, we wait for the temperature to go down. Now, as I mentioned, it's gone down 200 degrees in the time that we've been waiting. And another note as well, I started hearing water passing through the tube. You can definitely see that. So this is where we would pull out the tube, let it blow out its water for a couple of minutes, and then put it back in. I need to address this problem with facilities to make sure why exactly this is happening. That seems to be out. But we're at a low enough temperature that I don't think it's in any danger to the glass anymore. So this should be okay. But you see, yeah, the temperature's gone down very quickly, and the furnace temperature itself is reading about 82. That's maybe about 115, 120. But again, when you put the insulation back on, the middle and the most internal layers of the insulation will heat it up much faster. So this is why we need to wait about an hour. Alright, I just turned off the airflow for the 50 minutes that it was under cooling. We see that the temperature over here is reading 17 for the furnace and 18.8 for the reactor temperature. So we're going to come back over and put the glass wool insulation back over the reactor tube. So as I mentioned earlier, the internal parts of the reactor wall, those have not cooled down. The outer wall has. So for the first 15 or so minutes, the temperature is going to increase probably more than you think it will. Since we were cooling for about 50 minutes, an hour, it's not going to go up as much, but we want to at least give 15 minutes for whatever few degrees it's going to rise. I mean, we already see that we're at 19. It's probably going to go up another 5 to 10. So at this point, you're going to want to do your flow rate settings. You could have done this throughout the hour as well. So I see that this one's a little low, so I'm going to try to get that middle line. It's being really sensitive, so you got to be very careful that you don't overdo it. And it's probably going to go down a little, so I'll let that stand for now. And set your initial flow rates for whatever you're going to use. Since I'm going to be doing a light-off curve, I'm going to have the hydrogen here set to 40, and this one set to roughly 10. So wait 15 minutes and set your temperature to whatever your initial temperature is. For the light-off curve, that is going to be 28, 29. So I'm going to set that here now. If you're doing an Arrhenius plot and an order plot, you're going to be at 37, which will get you to 45 degrees. And if you're running a hydrogen order plot, you want to start at 60 degrees, so you're going to be at about 45, 46. So I'm going to set that to 29, and then we're going to put it back to normal mode after this 15 minutes is done. So you've already gone up half a degree over here, and that's just going to continue to slowly build up. At this point, I'm also going to check the bubble meter on my flow rates again, and when I'm secure with the flow, I'm going to open up the Alkyne bubbler. Now, when you open this up, you want to open it up in the shape of a Z. That means you open here, 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 as if you were drawing one. Now, it's very important that you never open this valve first, because this one's most immediately connected to the Alkyne bubbler. We've made it so that we can't really get Alkyne back up into the system like we used to, but we still don't want to take any chances there. So I'm going to go ahead and open that now. Swing that the other direction, swing it this way, that goes over here, and now the rhodometer flow rate is going through the Alkyne bubbler both here and at minus 20. And we see that we're at effectively minus 20 over here. So as long as this is going for about 15 minutes, the Alkyne should be at, it should cover up all the void spaces and be at the normal concentration that you would need for your test. If you notice you're a little bit higher, you can always adjust it, or a little bit lower. That is all done through the rhodometer. And you can use the GC software to set up your GC program. Alright, at this point I'm going to refer you to the cheat sheet to figure out how you're going to run your specific test. I'm going to be doing this one differently, so I'm going to stop following myself here, but we'll come back for the shutdown procedures. Alright, going to go over the shutdown procedures for the hydrogenation reactor. You always start the shutdown procedure when the last sample is going to be injected into the GC. So right now this is sample 18, and when that timer reaches half a minute or 30 seconds, you will hear the last injection. We're going to do 3 things in order. The first is we're going to shut off the Alkyne bubbler, we're going to hit the bypass, shut off the condenser, and then the furnace. That loud buzz is the injection, so we go over here. Remember, we want to go in the Z shape. So we shut these valves. Now the Alkyne is being bypassed. At this point, it is unimportant to have the Alkyne condenser on anymore. So we want to make sure that it's set to -20. If you were doing an order plot, then you will have to reset the condenser to -20 because at this point you're at 10. You don't have to wait for it to cool back down just as long as the set point is valid for the next morning. So to put it into standby, hit this little blue power button here. Now that's finished. And now we can go over to the reactor and we can put it into standby mode. For this particular test, I was at a different temperature, so don't mind the 36. You'll be at something different. And now we're in standby mode. So this is all we're going to do at this point. You heard that was the end of the GC injection cycle. So since it's already injected, we can shut all of these pieces off for now, because the only other piece that matters is currently working its way through the GC column. So we're going to come back at the end of this 14-minute test to finish things up. All right, the last sample has finished, so now we can finalize our shutdown procedure. So we've already shut down the bubbler, the condenser, and the reactor, so now it is time to shut down the GC. Now, as a note, if you want to take this time to look up the different GC files and tabulate your results and put them in the lab notebook, this would be a decent time to do that. You can also use this time that we're waiting to do just that, because it's going to take about another 5 minutes or so. But we'll set the temperature to 20. And you'll immediately hear the GC start to power down. So we can turn off the switch for the GC here once this is below 35 degrees Celsius. So what we're going to do next is we're going to turn off the mass flow controller. So we'll repeat this process again where we dial it out. Value will go to around 0. It's going to read about 1 when it's at 0 because it takes a little bit of time for that last bit of gas to work its way out. And I will continue to fail with using a screwdriver with one hand. I'm not sure if I'm picking up the clicking noise, but once you hear that noise, you might need to get your head in a little bit closer, but that tells you that we have hit the 0 mark. So, making sure that the nitrogen controller is already off, which it is, we walk over to the surge protector, and we shut it off. Now, it's very important that we do this, because if you shut off the gases, but you leave the mass flow controller, say at 50 milliliters a minute, is going to try very hard to hit that 50 milliliters a minute for the 15 or 16 hours that nobody's here in the lab. So when you get back, your 0 set point will probably be horribly off because it overheated and screwed up whatever 0 point it was already at. So I can fix that, but please try to avoid it because it's a pain in the butt. So I'm not going to show the shutting off of the GC right now because we'd have to wait a few extra minutes for that, but you would shut off the power. Or first, no, you would you shut off the power, or you can shut off the software first. In fact, I'm going to do that. When it tells you to save all before exiting, I say no. And the reason is because when you pull the software back up, it is going to set the GC to the temperature that you last put in. That will be 20 degrees Celsius for the cool down. So that's why if you open it up and it doesn't go up to 240, somebody probably said yes. So just keep all of that in mind. So I'm going to say no. Don't worry, your last sample file was saved if you let it go all the way to 14 minutes. If you didn't and you terminated the test beforehand, all you have to do is go to File, Save As, and then do this step. So I'm just going to say no. And then you'll be able to shut the GC down. And I'm going to shut off the non-essential gases as well. We don't need the lab air. And we're going to shut off the hydrogen so that gas isn't going through the rotometer overnight. Now there's a couple of key differences depending on the test you're doing. If you're doing the light-off curve and the Arrhenius plot, you're going to follow that procedure exactly as I showed you. If you did an Arrhenius plot with an octine order plot, the octine order plot comes at the end. Now your condenser would have been turned out to about 10 degrees Celsius, which means that we would have had much larger concentrations of octine put through the reactor system. That means it's still in these reactor lines, and they tend to linger throughout the night, and sometimes they get caught up here and cause blockages. Those have to be figured out later on through maintenance. So if you did an octine order plot, you can switch off the octine bypass. You can turn off the condenser after you turn it to -20, and you can turn off the oven, but keep the GC running overnight. You can turn off the mass flow controllers, but make sure that your rotometer is running at a low flow overnight as well. This will purge the system by the time it gets to the morning, and since you leave the GC on overnight, this allows bottlenecks to be avoided, like octine bottlenecks or oligomer bottlenecks within the tubing to be avoided. And that's it for now. Please see me if you have any more questions.